In the fourth unit of Calculus of Variation and Integral Equations paper, you can see this kind of problems. That is, they may ask you to determine the characteristic values. Okay, so here you can see the question. The question will be like this: discuss the solution of the integral equation y of x equal to this. We have to write the solution of this integral equation. Is that clear? So let us see what we have to do to find the solution of the integral equation given. So first write what is given in the question. Copy it down from the question. So write it, and you have to mark it as equation number 1. And in the next step, what you are doing is you are splitting. Okay, you are splitting the terms so that you will get this lambda integral 0 to 1, this 1 into y of epsilon d epsilon. So it is not necessary to put 1 here, right? So that is why you are not putting 1 here. Then put this minus, then lambda integral 0 to 1 3x epsilon into y of epsilon d epsilon plus this f of x. Okay, you are just splitting, and then what you are doing is equal to lambda integral 0 to 1 y of epsilon d epsilon minus lambda. You are bringing this 3x outside because this 3x is constant. Okay, keep epsilon terms inside the integral. Everything else other than epsilon, bring that outside the integral, so that here you are bringing 3x outside this integral. So you will write like this, plus f of x. Now so here y of x equal to, put this lambda, and in the place of this you are putting c1 minus 3x lambda, and in the place of this you are putting c2. Okay, so this is the value of c1 and this is the value of c2. Now put this plus and f of x, where c1 is equal to this and c2 is equal to this, right? Like that. Now what you are doing is, from this step you are taking lambda common, because lambda is common in these two terms, right? So take lambda common from that two terms so that you will get this. Now you are bringing this f of x to this side, that is, you are bringing this f of x in the left hand side, so that you will get this step. Now you have to integrate. What you are going to do is, you keep this. Okay, now what you have to do is, you are going to integrate this over the integral 0 comma 1. So when you integrate this in the interval 0 comma 1, right? So put integral 0 to 1 y of x with respect to dx, with respect to x you are going to integrate. Okay, that is why integral 0 to 1 this y of x into dx is equal to, put lambda, put c1, integral 0 to 1 dx. Okay, these two are constants. Okay, so that is why you are keeping this outside, and you will have 1 dx. It is not necessary to put 1 here, right? So that is why simply you are putting dx minus 3 lambda c2, and you are integrating with respect to x, right? So within integration you have to put x. So integral 0 to 1 x dx plus, and then integral for this also you are putting integration. And then here look at the value of c1. This is the value of c1. Here also you are having, this is also c1, but the only difference is, here in the place of epsilon, here you have x. That is the only difference. Other than this is also the value of c1. Okay, so you are, instead of this value, in the next step you are putting c1 is equal to, now you are integrating this. Okay, so when you integrate this you will get this. When you integrate this you will get this, and when you integrate this you will get this, and you are writing this term as it is, the previous step. Now what you are doing is, you are applying limit in this step so that you will get this. Now you are writing like this. Okay, so after applying limit you will get this step. Now you are bringing all the terms except this to the left hand side, so that you will get this equal to this. Now here this is all C1 term, and this is also C1 term. So from these two terms you can take C1 common, so that you will get this plus 3 by 2 lambda c is equal to integral 0 to n f of x dx. Okay, mark it as equation A. And now we have equation 1 here. Okay, you are going to use this. Okay, you have to mark this as equation number 1, and you have to use this in this step. You are multiplying x with this equation number 1. Okay, so that you will get this step, and you are integrating this over the interval 0, 1. That is with the interval this, and you will integrate this with respect to x. Okay, so did you see that? Okay, so in the next step what we have to do is, here you can see you are integrating. Okay, so that you will get this. So in the place of this term you can put C2, because this is the value of C2. Okay, already you have it, but here you are having epsilon. That is not a matter. In the place of epsilon, here you have x. Okay, there is nothing to bother about epsilon and x. Okay, so here this is in C2 format, right? C2 format. So you are substituting in the place of this, you are substituting C2 is equal to lambda C1. You are integrating, so that you will get this step. Now you are applying limit. When you apply the limit, you will get this step, and this term is, you should not disturb this term. Okay, keep that as it is. From this you will get this, and you are bringing all the terms except this to the left hand side of the equal to. Okay, equal to left hand side, so that you will get this. So from this, here this is C2 and this is also C2. So from this you can take C2 common, right? So that is how you will get this step, and mark it as equation number 2. Now you are finding delta lambda. So how you have to find delta lambda? You will find delta lambda with the help of this small a and small b equations. Okay, here you can see small a equation, and here you can see small b equation. So using these two equations you will find delta lambda. So here put determinant. This is C1, coefficient of C1, and this is coefficient of C2. Is that clear? Now you find the determinant of this value. You will get this. Put delta lambda is equal to 0. So here you have delta lambda value. So this value equal to 0. That is how we are putting. So from this you are finding the value of lambda. You will get lambda is equal to plus or minus 2. So in case 1, if lambda equal to 2 means you will do something, and after doing that you will say if lambda equal to minus 2, there also you have to do some of the steps. So here if lambda is equal to 2 means you have to apply the value of lambda in equation A, this A and this B. Okay, so here when you apply you will get this kind of equations. Keep this and mark it as C and D. Okay, after that what we have to do is, you are considering f of x equal to 0. Okay, you are considering what? In the next step you are considering f of x equal to 0. So here you are going to put f of x equal to 0 in C and D equations. Okay, what is C and D? This is C and D, right? So in these two equations, in the place of f of x you are going to put what? 0. Okay, 0, right? Yeah. So when you put 0 you will get this, and from this you will get the value of C1 is equal to 3C2. Now what you will do is, in our equation number 1 you will substitute, in the place of C1 you will substitute 3C2. What is our equation number 1? I think equation number 1 is the given equation. Okay, the given equation, simply I can say like that. So here in the given equation, when you apply, wait a minute. In the given equation, you are substituting, so not in given equation, in this equation. I'm so sorry, in this equation. Okay, I have marked that so as equation number 1, and this is wrong actually. Cut it. This is equation number 1. In this equation you are substituting the value of lambda and c1 value also, and you will put f of x equal to 0 also in this equation, so that you will get this. Okay, so that from that you will get this, and here in the place of 6c2 you will put ca, so you will get like this: y of x equal to a of 1 minus x, where a is equal to 6c2 is an arbitrary constant. This is an arbitrary constant. Okay, so now in the next what you will say is, if lambda is equal to minus 2 means you consider equation a and b. Okay, like the way you did for if lambda is equal to 2, what you have done, the same thing you will do for if lambda equal to minus 2. Consider these two equations, and in these two equations, in the place of what? Lambda, put minus 2, so that you will get these two equations, and consider f of x equal to 0 in these two equations, so that you will get like this. So put c1 equal to c2 and lambda equal to minus 2 in our equation number 1, so that you will get this. So in the place of this you will put b. Here b is an arbitrary constant. Now you have to write these two sentences, that is, when lambda equal to 2, you are getting a characteristic function, that is 1 minus x. When lambda equal to minus 2, you are getting another one characteristic equation, that is 1 minus 3x. Okay, this problem is not ending here. Remaining part is also there. I will upload it in another video.